Okay, so I'm going to do a couple of examples about adding fractions with unlike denominators. And I'm going to use two different methods. One method you might be, of course, familiar with called the LCD, which is least common denominator. But then there's also another way you can do it, which I'm going to use this first one as an example, called the ECD, or in other words, the easiest common denominator, okay? Of course, we're used to this one, and if you're really good at that one, by all means, do that one. I don't want to mess you up or put anything extra in your head and then you get confused, okay? I don't want that. But if you find that you have trouble doing this version, then maybe this one might help you out a bit. So what you wind up doing in order to find the ECD and then be able to add these straight across, because you know whenever you're adding or subtracting fractions, you have to have the same denominator. You can't try to add these different denominators together or anything like that. You have to have the same denominator, and it has to be that same answer in the end. You can only add the top, okay? So the way that, of course.
At this time, all core classes in the pod,
Sorry.
please go to 6th period. All core classes in the pod, please go to 6th period. Thank you.
Anyway, the way that you wind up going about this method is you're actually going to take the product of these two denominators and multiply them by each other, okay? So how I would do that, this is a 2, of course, so I'm going to wind up actually multiplying this fraction, the other fraction, by 2 over 2, okay? And then this is a 4, obviously. This is our second denominator, so we're actually going to wind up taking 4 over 4 and multiplying it by the other fraction. So that's what I mean whenever I say the product of each other. They're actually going to kind of switch, okay? So whenever you wind up doing these little multiplication problems with the fractions, you know at multiplying, you can just multiply straight across. So that's what I'm going to do for both of these. So 4 times 1, and I'm going to write it right here. 4 times 1 equals 4, and then 4 times 2 just equals 8. We had a plus sign. And then for this part, so we've got 1 times 2, that just equals 2. And then 4 times 2 equals 8. Boom. So now you have matching denominators. Now you can go ahead and just add straight across. All right, so our denominators, of course, have to stay the same. So that has to stay in 8. And then at this point, we've got 4 plus 2, that gives us 6. All right, and then we have to make sure we are able to figure out when things can be simplified. Your best trick that you can think of, that you probably might think of, is just at least seeing if you have 2 even numbers. If you got 2 even numbers, one in the numerator, one in the denominator, you know you can at least be able to simplify by 2, or in other words, divide by 2. All right, so then I get 3/4. And just enough space because I ran out. And that is our method on with ECD. Okay, so now with LCD. So this one is the one that I'm sure y'all learned in the grades before. So with LCD, you actually wind up finding common multiples between the two denominators. So instead of taking them like we did here and multiplying like that, you actually find multiples that these have in common. So what you wind up doing is just kind of listing your multiples. All right, so let's see, 3 and 5. So if I'm doing times 1 here, then 1 times 3 is just 3. 1 times 5 is 5. All right, what about times 2? If I got 2 times 3, that gives us 6. 2 times 5 gives us 10. Times 3, because I still don't see anything matching yet, so I got to keep going down. So 3 times 3 is 9. 3 times 5 is 15. Still nothing matching yet. Times 4. So 3 times 4 is 12. 4 times 5 is 20. Nope, nothing yet. Times 5. This might be it. So 3 times 5 is 15. And then 5 times 5 is 25. All right, so do I see any numbers duplicating themselves? I do, 15. Boom, boom. So for our 5, it took 5 times 3 to get that. And then for our 3, it took 3 times 5 to get that. So that's what I'm actually going to use here, all right? So I'm going to go ahead and just rewrite it over here. So 2 times 3 plus 4 times 5. All right, so I'm going to wind up using that 15 as a denominator. And then I have to make sure I do the multiplication work to be sure to, I guess, not project, but to display how I got that. So for 3, I said it took 3 times 5. And then automatically, whatever you do to the bottom of a fraction, you have to do to the top. So boom. And then right here, it took 5 times 3 to get that. And then automatically, what you do to the bottom, you got to do to the top. So then at that point, we already got our denominators solved. So we're all done with this. Now we just got to multiply the top. So 2 times 5 is 10. Put in my plus sign there. And then 4 times 3 is 12. Then after that, now you can just add straight across. So your 15 has to stay 15, and then 10 plus 12 gives us 22. All right, so then I'm just going to go ahead and turn this into a mixed number, because just looking at it, it looks like I can't simplify it down anymore, but I can at least transform it into a mixed number. So all you do is just divide the top by the bottom. So then there's one group of 15 inside of 22, so I know that's going to be 1. And then I'm just going to do some little math right here, because I can't remember what 22 minus 15 is. Boom, boom, boom. 7. So 1 and 7/15. And my paper won't stay still. I'm going to hold it, and there we go.